All right. So this section starts probability. So we'll look at permutations and combinations, and well, we'll start with the counting principle and stuff, and leads into permutations, combinations, and then we'll go from there. But this week we will primarily focus on permutations, combinations, and the counting principle itself, and we'll look at a couple of different things. So if you've looked at Canvas, I have got the stuff listed for the week 316 through 320. It's got Monday, it's got Tuesday in there. The assignment's already up there. It's about 20 something problems for you to do. One of the problems is another video that kind of goes through permutations again. So that way you've got another look, and I really like it. It's short and condensed, and it's to the point. So it may be a little bit easier to do a refresher using that. So that is one of the problems. So the first thing that we've got to talk about is fundamental counting principles. And fundamental counting principles are when multiple things are happening. You know, the first event, E1, can occur in M different ways. After E1 has occurred, E2 will occur in different ways, so forth and so on. So, and we can extend that into, instead of one or two events, we can extend it into multiple events, meaning M1 times M2 times M3. So the first thing that we kind of will look at, it kind of gets you started, is this. Using the fundamental counting principle, how many different pairs of letters from the English alphabet are possible? Well, if you look at this, pairs means two, right? So how many different possible letters would be viable for the first one? So let me do this. All right, so I've got you unmuted. So how many different letters could be viable for the first one?
Two.
Two?
Two. It's 26.
26. Yeah, that's probably not going to work. So put your stuff in the chat thing. So the number of possibilities for the first letter would be 26, because there's 26 letters in the alphabet, right? And then the number of possibilities for the second letter would be also 26. So what we're looking at is really 26 times 26, which is, if you got your calculators out, 26 times 26 would be 676 different pairs. Okay, so if we were to take the two letters, and they're pulled from the alphabet, we have 26 choices for the first letter, and then we would have 26 choices for the second letter, which would give us a total amount of choices or options or results of 676 pairs. Okay, so just want to kind of make sure that you're good with that. All right, so I kind of want you to do this one, and then you can put your answers up in the chat box. That way we can see. So, in how many ways can a 6-question true-false answer or true-false exam be answered? So, what I want you to do, assume that no questions are admitted. So, I'll go ahead and here's question 1, here's question 2, 3, 4, 5, and 6. So, I kind of want you to look at this and see if you can figure out how many different choices or different ways that we can answer a 6-question true false. Okay, So I'm going to hit pause on the. All right. So let's think about what would be the possible answers for the first question. And there's only two possible answers, right? And let me do that. Okay. So the first answer is only two possible answers, true or false, right? And for the second one, again, there's only two, right? True or false, right? Third one, two, true or false. Fourth one, two, true or false. Fifth one, two, true or false. And then sixth one, two, which would be true or false, right? Now, notice that the counting principle says that each one of these choices or options are multiplied together. So if you think about this, this is 2 times 2 times 2 times 2 times 2 times 2, which is really 2 to the 6, which is 64, right? So those of you that had 32, those of you had 12, do you see where your mistakes were? You know, at each question, I'll have two possibilities, true or false, right? So, okay. So anybody have any questions about how we got 64 on this one? If you do, put it in the chat box, and then we'll go from there. Okay. Give you a couple of seconds here. All right. So let's go on to the next one. Looks like everybody is okay on that. So, all right. So let's take a look at this one. This one's a little bit similar, but I kind of want to lay out some stuff and kind of get you kind of started on it. Telephone numbers in the United States having 10 digits. So the first three are the area code, okay? And the next seven are the local telephone numbers. How many different telephone numbers are possible within each area code? So we're not going to look at the area code, right? That'd be the first one. And then there's seven that are the local. Note that at this time, a local number cannot begin with a 0 or a 1. So just want to kind of get you started. So we're looking at this dash 1, 2, 3, 4, right? So we said, it said for the first one, it cannot begin with a 0 or a 1, right? So the numbers that I have available is, can't use 0, 1, so it leaves me 2, 3, 4, 5, 6, 7, 8, 9, right? So that leaves me 8 numbers here. So I want you to think about what your possibilities for the rest of these are. So I'm going to give you just a second to kind of do this while I answer some text and stuff that are coming in from different students. So, all right. So let me turn my recording back on. We said that because the first one was restricted, the only numbers could be 2 to 9. So it left the other one having 10 possibilities of 0 through 9. So just kind of want to make sure everybody's good with that. If you got any questions, let me know. If you turn down your sound a little bit so that it's not loud, we'll see if the feedback won't be as bad. Yeah, that was what I was afraid of. Yeah, there's a lot of feedback on different ones that haven't got their mics turned down for different things. So yeah, I'll make the homework. Yeah, I'll go and no, I want you to do. Yeah, I'll make it. Somebody asked a question on homework unlimited attempts. Yeah, I'll go. I put it as 2, but it's not going to allow you to do the unlimited. So I'll go back. So those of y'all that may have been checking out your homework, in order for me to make that change, it has to be cleared. Okay. So uh, anyway, anybody got any questions about how we did this particular one? Anybody? All right. So if you do, just put it in your chat box right there. But the answer would be 8 times 10 times 10 times 10 times 10 times 10 times 10, which is 8 million. So a local telephone number has 8 million combinations, right? Uh, as far as distinct choices. All right, so let's look at the next one. Permutations. One application of a fundamental counting principle is determining the number of ways an n element can be arranged in order, right? Order matters. So when you talk about permutations, order matters. So an ordering of n elements is called permutation. So n elements is an ordering such that one element is first, second, third, or fourth. So you'll see it like this. Or you may see it in PR written like that, or the 2 notations that you have. And so the N here would be the total number of items that you have. And then R would be your choices, or how many of those you want out of that, right? How many items are you looking at? So just so you kind of know, and we'll work it on the next one, but let's kind of look at this one. How many number of permutations of n elements? How many permutations possible for letters A, B, C, D, E, and F? Okay. So let's just kind of go through one and make it a little bit more sense. If you consider this, Jakiria, you had a question on the previous one about how did I get 8 on this one right here. They limited that the first one right here could not be this number right here. This first digit couldn't be a 0 or 1. So couldn't equal 0 or 1, right? So that took 2 away from there. So that's why. So all right, so let me get back to this one. All right, so how many possible permutations are possible for letters A, B, C, D, and E, and F? So if we look at the first position, any of the 6 letters, right? So if we consider this 2, 3, 4, 5, so it'd be 26 there, right? Or not 26, my bad. It would be 6 because we're using 6, right? Any of the 6 letters. And then the second will be 5 letters, and the third would be 4 letters, and then the second one, and then of course 6, 5, 4, 3, 2, 6, 1, 2, 3. Okay, one more right there. All right. So if you multiply those all together, what do you get? So if we take 6 times 5, 6 times 5 times 4 times 3 times 2 times 1, that gives me a total of 720. Okay, so what I want you to kind of get off this problem is how do I, if it's a descending order and I'm doing 6 times 5 times 4 times 3 times 2 times 1, we can really simplify this multiplication as 6 factorial. Okay, so this right here, little exclamation point, means factorial. Okay. So that's going to be used and used a lot. So to understand 6 factorial, what that really means, or what that's really saying is saying start at 6 and you're multiplying every number all the way down to 1. Okay, so factorial says 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. Okay, all right. Any questions on that one? Kind of walk through it together. All right, so let's look at this one. Well, that was the same thing. 8 horses running in a race. In how many different ways can these horses come in first, second, or third, right? So I'm going to assume that there are no ties. So I'm going to let you do this, okay? So I'm going to give you a second to do this. I'm going to stop the record. And I didn't turn that back on. All right, so let me repeat that so that y'all can see it. There's 3 orders, right? Or say 3 orders. There's 3 different, so there's first place, there's second place, and then there's third place, right? So to win first, there's 8 horses. In second place, well, after the first one wins, there are only 7 that could get second, right? So that's why it's 7. And then for third, after second place is given, you only got 6 left. So that's why it's 8 times 7 times 6, which is 336, right? So that's a counting principle. So that kind of becomes, when you get into a lot of things, it could be kind of bothersome to do something that is that large of a number. You know, if we're looking at 12,000 or something like that, or 200, you wouldn't want to do and looking at 30 spots, 200 things, 30 spots, how many different ways we can do that. That kind of gets crazy. But these ones that are small like this are not. So I want to show you, this is the equation that we're going to use for permutations. Okay, so it's NPR, n elements taken r at a time, right? N is the total number of elements. R is how many do you want, right? How many of those? Like in the previous problem, well, we'll look at the previous problem. We'll do it with this right here, and we'll see it. So once we determine what N is, we'll go N equals what, and then R equals what. And once we get those, N is always the total, right? R is really how many of those you want at a time, right? So I guess you could say the number of choices that you want. So it's n factorial over n minus r factorial, okay? So you got to do the n minus r here. So you need to get this particular equation right here written down. Make sure that you have it, okay? Let me go here. Highlighter, you want to get this, okay, in your notes, because that is what we're going to use, and that's going to be critical or crucial as we move forward here, okay? All right, so I've given you, you should have had time to write that down by now and everything. And this is going to be up in a video so that you can take, go back and look at problems and do that. So I want you to kind of consider this one. If we look at what we just did with the 8 horses and everything, we wanted and how many different ways can 8 horses finish in first, second, third, right? So the N would be 8, the R would be 3, right? 3 choices. Yes, I'll be putting it. It'll be up in Canvas. It'll be under Monday lesson on permutations. Okay, so you can look back on. And 2, there's a question within your homework that is a video that really goes over it as well. So I really, really like that video as well as what we're doing here. Okay. So there's 8 factorial, right? Or 8 horses, and 8 minus, this is really in, well, let's see. This is really N minus R, right? So it's 8 minus 3, which leaves me 8 factorial. So I want you to kind of consider this. As they're doing this, is 8 times 7 times 6 times 5 factorial over 5 factorial. The reason that this works is we're only considering the first 3 spots. Okay, we're not considering all the spots. So the reason why the denominator's there, the n minus r, is to take away the other spots that are not being considered. That's why 5 factorial below and then the denominator being 5 factorial below cancels out, right? So if you look at that, we're really only like 5 times 6. If I can, let's see, do that right. 6 times 5 times 4 times 3 times 2 times 1. And then, of course, on the bottom is 5 times 4 times 3 times 2 times 1. If we were to look at every different places, if we look at how many different ways that we could have finishes for all 8 horses, then that would be the top, right? Just the numerator 8 factorial. But this said, how many different ways can 8 horses come in first, second, or third? So we put a limitation on how many we're using. We're only looking at really these first 3 spots, 8 times 7 times 6. And these actually are getting canceled. These are the spots that are there, but they're getting canceled out. Okay, so that's why you see this 5 factorial and the 5 factorial here being canceled out. So please make sure that you are aware of that. Okay. All right. Any questions on that? The formula is going to help you, and we're going to do about 4 problems that I want you to kind of look at, and we'll check them and everything. But any questions? People dropping every which way. 21 people in attendance. All right, just say what you got. So there's 8 horses, right? So they are only finishing. We only are considering the first 3 spots, right? First, second, third place. That's it. We're not considering all 8 finishes, or first, second, third, fourth, fifth, sixth, seventh, and last place. We're not considering all those. We're only considering the first 3, right? So that's where the R comes in. What it's going to do is it's going to take away, and that's what the denominator, n minus r, that's the denominator. It's going to help us know what's there. All right, so we're going to do some problems, okay? So let's kind of look at this. All right, so you got a group of 45 people going to run a race. The top three runners earn gold, silver, and bronze. Okay, so how many different ways can those 45 people be finished, right? You got 45 people. How many different people could finish first, second, third, gold, silver, or bronze, right? So kind of want to make sure that you are with this. N is the total amount of people, right? Right? And then R would be what? Gold, silver, and what? Bronze. It's kind of like first, second, and third, right? So that's this. So remember that permutations is equal to n factorial over n minus r factorial. So take about a minute, make sure about 30 seconds, and let's see if you can do this one, okay? All right. They're telling us they want to unlock or unblock GoToMeet, that we have to use Google Meet. So we'll try that after we get done with this. So let's go and looking at this one. If you look right there, it's 85,140. Okay. So let's go to the second one. All right. So 50 applicants with 4 jobs. And the 4 jobs are computer programmer, software tester, manager, and systems engineer. Right. Yeah, but not everybody can. We really need to be having it on your computers and not that. So we'll give their a try, okay, guys. But don't delete the app or the link. Okay. All right. Put your answers in the chat box, and we'll go from there. All right. So if we were to look at this would be in R. So if we were to come across it written like this, let's see, 4 jobs, it'd be like that, right? Or in PR, which would be 50P4, right? Kind of want you just to kind of make sure that you know the 2 different ways. So it's n factorial over n minus r factorial. So what that becomes is 50 factorial over 50 minus 4 factorial. So when we're looking at this, it'll be 50 times 49 times 48 times 47. And then let's look at this. This would be 50 minus 4 is 46, right? So it'd be 46 factorial. And at this point, we got 46 and 46 cancels, right? So yeah, there's 50 different selections that we could choose from, but we're only looking at a combination. I hate to say combination, but how many ways that we can make or arrange them in the first 4, right? So if you do the math on that, it'd be 50 times 49 times 48 times 47, and that would be, I'm getting this, 5527 200. Okay, so let me check my chats real quick. Yep. A lot of people got that. Let's check it on here. Just kind of make sure. Okay, 5,527,200, right? Isn't that what we got? Yeah. All right, so let's do another one. Just kind of get your feet wet just a little bit more. I won't say anything. I'll give you just a second to do this one, okay? So I'll cancel, stop recording, and I'll start it back. So I'll give you, I don't know, a minute. Go. All right. So let's kind of look at this and check some of y'all's answers. I'm going to go back and fix the homework, guys. So don't start working on homework yet, okay? Because I'm going to clear your stuff. All right, so got some 2,184s. So let's kind of see what everybody's got. Okay. So they're planning trips to 3 countries this year. There are only 14 countries they'd like to visit. One trip would take 1 week, 2 weeks, and the other is 3. So if we look at this, I'm saying N is 14, but R is 3. They're only planning to visit 3 countries out of the 14, right? I don't really care if they're 1 week, another 2 days, and the other 2 weeks. That's kind of irrelevant. So let's see, P14.3 or 14P3. And if you look at this should be 14 factorial over 14 minus 3 factorial, which would be 14 factorial. 14 minus 3 is 11, right? So if you look at this, 14 times 13 times 12 times 11 factorial over 11 factorial. The 11s do what, guys? Cancel. So I'm saying 14 times 13 times 12. And I get 2,184. That's what I'm getting. Okay. All right. So does that help you a little bit more? I think most people got 2,184 for their stuff. All right. I had another one here, but I think we'll forego that because I think people are okay with that. I want to look at this and distinguishable permutations. Let me ask this question. Okay, let me go back and give you some time to copy that. Sorry. There you go. The thing that we're going to look at next is taking a word and figuring out how many different ways you can arrange things and stuff like that. So that's really where we're going, okay? So, everybody good? Yep. All right, so let's look at this. All right, so suppose a set of n objects has n1 of a kind of object, n2 kind of a second kind of object, n3 is the third kind, and so forth. So the number of distinguishable permutations of n objects is n factorial. That's how many do you have, divided by how many distinct sets of objects you have. Okay. Now, why is that important? Well, you need to make sure you have this copied down, right? Distinguishable permutations, it's really this, right? Okay. And N1 would be one kind, N2 would be another kind, N3 is the third kind. So make sure I'll wait while y'all copy that down. All right. All right. So this particular one will be used for a distinct look. Okay. It's the n factorial over the different ones that you have. Now let's kind of look at this to kind of see what we're looking at. Here's how many distinguishable ways can the letters banana be written? Well, first off, how many letters? So there's 1, 2, 3, 4, 5, 6. So n is 6, right? Now let's do this. So we know it's n factorial over the individual ones, right? Like, let's see. Okay, let's look at B's, let's look at A's, let's look at N's. How many we have of these, okay? So how many B's do we have, right? And I only see 1. How many A's? There's 3. And I see 2 N's, right? So these are the objects, right? So if we go like B factorial, A factorial, N factorial, that's how many times. Well, they're not budging on that. So how many times do these letters set up? Okay, so here's what we've got. We've got 6 factorial over. There's if it's a 1, guys, 1 factorial is nothing no more than 1. Okay, so we really don't have to, but I'm going to put it in here. 1 factorial, that would be the B, right? We know it has no significant effect, right? And then A, I have 3 A's, right? And then I have 2 N's. Okay, so I've got, if you look at this, we've got 6 times 5 times 4 times 3 times 2 times 1 over, let's see, that's 3 times 2 times 1, right? 3 factorial. And then I'll change this and I'll put it 2 times 1. So all right, so let's kind of look at this. So 3, 2, and 1 cancels out 3, 2, and 1 here, right? So we still are left with 6 times 5 times 4 all over 2 times 1 is just 2, right? So 6 times 5 is 30. 30 times 4 is 120 over 2, which equals 60. So in how many distinguishable ways can the letters banana be written? Be 60 different ways, okay? Order matters, all right? So just kind of make sure. That's how you do this particular problem. And you'll have a couple of these in your homework. But the biggest thing is list out how I've done here. But I have 1B. The other one is this. Some people are asking, why is there another 2 times 1? Well, B factorial, A factorial, N factorial, right? How many of those? So we didn't put the B because the B is 1, right? Well, we did. We put it here. If you look at it, we put it here, and let me do it with a different color, red, A, and then N, right? So there's only 1, so we ain't got to worry about that. 3 factorial is 3 times 2 times 1, and then a 2 factorial is 2 times 1, right? So when we listed out the top, we were able to cross out the 3, 2, and 1 with the 3, 2, 1 down here, and left us with 6 times 5 times 4. Well, 2 times 1 is nothing more than 2, and that's where that came from. So it'd be 120 over 2, which gave me 60 different things. All right. Is that, hopefully that makes a little bit more sense. Okay. So, yep. All right. Now that's for the ones when you got words. Okay. If you'll do it like this, it will come out slick. You won't have a problem. Okay. Now let's talk about while I've got you, and everything, because that's really the last look. Well, there you go. Shows the solution. Let's look at where things are. Let's go to home. They're not going to let us use GoToMeet. They're saying they're not going to unblock it. So we're going to have to look at Google Meets, and I really haven't looked at Google Meets, but I guess we'll have to. So let's see where things are and how you can stay up on your stuff. Go to my Nola had a question. What do you do if you have 65 factorial or 42 factorial? Well, you list 65 times 64 times 63 all the way down to 42 factorial, so you can cancel out the denominator. So all those would be multiplied, right? Now, when we get back, you'll have calculators that can do the permutations. You type the N, the R, and it'll do it for you, right? But we'll try not to have some ones that are like 65 or 42. So that'll put your mind at ease a little bit. Okay, so what you should see and what you should pay attention to is this. Lessons for the week 3-6 through 320. The first one's permutations, and of course there's a homework that's assigned to it through online math through Canvas. I'll put the video up. I'll just list it in here so that you can see it and I don't have to worry about it. And so tomorrow, what does tomorrow hold? Well, tomorrow will hold a online help session or reteaching, and I will be taking questions from the homework. Okay, so after tomorrow, when we finish tomorrow, you should be just about all your questions answered as far as things that you ran into when you were doing this within Canvas. Now, I did leave. There's certain problems that do have videos that are attached to the bottom of them. For example, if I go to this, it's going to open. Let's see if I can kind of scoot through something real quick. 1 o'clock tomorrow. That way it gives you a little bit more time, and I'll put that in it. Would you have to sign into that meeting? We didn't have any questions, or we just do the homework. Well, I need you to sign in. It's kind of like showing up for class. We'll go over some things, and then I'll say, okay, if you're good, then you're good to go. And if you're not, then of course, stay on. We'll get your questions answered. But I left within these questions any kind of help stuff. And like if you get confused on how to work a problem, something like that, there's a video for this specific type of problem. So it kind of gets you. So I'm leaving all those hints and stuff there to help you along the way, which is real good. But there'll still probably be questions that you have tomorrow, and that's what we'll address at that time. Okay, so okay, I'm not looking at 24 yet because I need to clear, and whatever work you've done on this while I've been talking, it's going to be cleared because I got to change all my settings, so it's going to clear your attempts. So I'm sorry, but to make it where it's unlimited so you can practice, that's what's going to happen. But I do want y'all to do real quick is I will send an email for Google Meet, and we'll end this, and then we'll ask you to get on an email for Google Meets, and let's just kind of look at it today. Let's go ahead and look at it and see what it all does. Okay, so that's all of